Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover the ninth chapter of credit and the name of the chapter is compound interest. Students, let us see what are the different topics we are going to cover under this. So we are going to understand what is compound interest, how to find the formula of compound interest and how to calculate the compound interest using formula, and we'll see the use of compound interest in different cases like depreciation or appreciation of a product, yes, or the value of product. So let's start with the first topic, concept of compound interest. Students, we know what is a simple interest that we have already understood in our previous class, where interest was calculated on the principal amount. Let's suppose we have 1000 rupees and it was given to someone on at the rate of 10% per annum for 2 years. Then we use the formula of simple interest is equals to P times R times T over 100. So the total interest, that is the amount other than the principal amount that the giver will receive, is 1000 times 10 times 2 over 100, and if we'll solve this, we will give 200. It means 200 rupees will be the extra amount paid by the you can say the debt taker to the giver. Yes, so this was the simple interest that we know. Yes, now in some cases there is another interest that is applied, which is called compound interest. This is the interest on interest. So interest is taken on the principal amount as well as on the interest also. For example, let's suppose 1000 rupees invested in a bank, yes, and it was invested for 10% per annum compounded annually for 2 years. So what will happen is, after 1 year, the bank will give 10% of what the percentage of rate was given. So 10% of 1000 is 100 rupees. So after first year, the bank will have 1100 as the saving money from the customer. Now bank has to pay 10% on the amount of 1000 as well as 100. So now 10% of 1000, that is 100 more, and 10% of 100, that is 10 more, is given for the second year. Now the total amount becomes 1000 plus 100, the amount of the first year as interest, and 110, the interest for the second year, which will give us 1210. So in the simple interest, where there was interest of 200 for the 2 years, the interest in compound interest is more, which is 210 in 2 years. So compound interest is basically interest on principal as well interest that has been obtained over the period. Yes. So compound interest is founded out by finding out the amount minus principal. That is, the amount was 1210 and the principal was 1000. So we can calculate the compound interest represented by CI. Okay, it is a short form of compound interest. Now, how to find out the compound interest? So I have told you that you can find out the simple interest for the first year, then the new principal amount will be there for the second year, and again the principal amount will be changed, and we can find out the interest for the second year using the simple interest formula. Like, find the compound interest for 12,000 for 2 years at the rate of 5% per annum when the interest is compounded annually. It means per annum it is compounded. So 12,000 is the principal amount, rate is 5%. So interest for the first year is 600, but the new amount or the new principal is 12,600. For the second year, the principal is 12,600. Now interest will be on 12,600. Yes, so it will be 630. So you see the interest every year gets increased due to increase and the change in the principal amount. Now after 2 years, the amount is total, it will be 12,600 after the first year and 630 after the second year, that is as an interest. So the total amount will be 13,230 rupees. Yes, so this is the way of finding out using the simple interest formula. Now the second topic is compound interest formula. So instead of finding out simple interest over the year again and again, we can have a direct formula, and the derivation you can go through where they have applied that how much will be the amount after 1 year, then 2 years, then 3 years, and a general formula is obtained where A is equals to P 1 plus R over 100 over N is given, where R is the rate of interest and N is the time period for which the amount is taken. Yes. So here for a compound interest, that is, let's suppose after 10 years I want to find out the compound interest, not the principal. Yes, so we can subtract the principal from this amount. So P1 plus R over 100 raised to the power of n minus P. So this will be represented like this, and if you take P as a common, this will be the final expression for compound interest. Now let's apply this formula in an example. Find the amount in compound interest for rupees 10,000 for 2 years compounded annually at 5%. So principal amount is 10,000, rate of interest is 5%, time period is 2 years. Now you use this formula, 10,000, 1 plus 5 over 100, n is 2, 10,000, and the calculation will be 10,000 times 21 over 20, and the final answer will be 11,025. So this is the amount, that is the total amount after 2 years. Yes, but if you want to calculate the extra amount, that is the compound interest, so it will be the total amount 11,025 minus 10,000, which is 1,025. Yes, so compound interest for the same time period at the same rate of interest and on the same principal amount is always greater than the simple interest other than the first year. Yes, on the first year the both amount is same. Now sometimes n will be unknown, that is the time period can be unknown or principal amount can be unknown. So same formula is used, and then we can shift one value to the other side and find out the unknown values. Yes, now let's suppose we can have different interest rate for different years. Sometimes for the first year the interest rate can be different, and for the second year the interest rate can be different. So for that what we do is, let principal is equals to P, time is equals to 4 year, and let the interest rate be R1, R2, R3, R4, etc. Now to calculate the principal amount, the final amount, we can use the formula principal times 1 plus R1 upon 100 into 1 plus R2 over 100, and similarly as till as we want for 4 years or 5 years, and this will give us the total amount accumulated after n years. It means the number of years you want, yes, at different rate of interest. So let's apply to one problem, and if we have Venu lent 70,000 to his friend on the condition that is the interest payable for the first year, second year and the third year will be 5%, 10% and 12%. Respectively, find the amount of compound interest that Venu will receive. So amount will be calculated like this, and in calculation we have this, and after this we will have 90,552 as the final accumulated amount. Now for the compound interest we can subtract 70,000 from 90,552, which will be 20,552. Now student, moving to the next topic, growth and depreciation. Students, the topic of compound interest can be applied to different real life application. One is growth and other is depreciation. So there are two type of product. One is a product whose value can be increased with time, and other product can be values can decrease with the time. Like let's suppose if I buy a car today, then after 10 years its amount will be less than what I have paid now. But let's suppose if you buy a land, then we can have a price, and after 10 years from now we will have a bigger price than what I have bought as of now. Yes, so growth and depreciation. Growth means increase in something, and depreciation means decrease in something. So if a constant growth or a specific percentage of growth or depreciation happens, we can calculate the final amount that we have. Yes, so the time period play an important role in the study of growth, which can be either positive or negative. For example, the population of India was 23 crores in 1951, increased to 101 crore in 2009. So it means there is an increase or growth of population. Yes, and in contrast, the cost of machines like televisions or bikes or cars decreases with time. Yes. Now, for growth, we have a formula. Let's suppose if the growth is constant, we can have a formula A is equals to P 1 plus R over 100 raised to the power of n. And for depreciation value, that was the final depreciated value, for that we can have a formula P 1 minus R over 100 raised to the power of n, because there is a depreciation, so negative R is taken. So this is the formula. And sometimes the rate of depreciation or growth can be different for different years. So we use this type of formula that we have, where in case of growth we use amount times 1 plus R1 upon 100 or R1 by 100 and so on. And for depreciation we use 1 minus R1 by 100 times 1 minus R2 by 100 and so on. So this is quite similar to what we have understood and the compound interest case. So let's take an example. In a town, the population was increasing at 2% per year. Find the total population after 3 years if the present population is 1,25,000. So we'll put the value like this, and 2 over 100 will be simplified to 1 over 50, and if we calculate this we'll get 1,32,651 as the final population of the town. So if you want to calculate the increase in population, we can subtract the initial population from the final population. Yes. Similarly, for a depreciation case, we can have a negative sign over here and we can calculate the value. Yes. Now students, so this is all from this chapter. I hope you have understood the concept of compound interest and its application in growth and depreciation, and you can try the questions based on them. Just you have to look upon the rate of interest, the time period you are given with, and in case of growth and depreciation we have to look either the product will be increased in the price or decreased in the price, and you can find out using the given formulas. Yes, so we'll meet in the next session for the next video. Till then, keep practicing, keep learning.